Hi again, everyone. This is Wes Baxter, math faculty at Nashville State Community College. In this video, we're talking about solving problems involving functions. And I'm really excited about this particular presentation because we're going to be bringing together a few things that we have discussed up to this point and sort of bringing it full circle for you in this recording. So it's going to be great, hopefully. Before you watch this recording, I would suggest and recommend that you make sure that you have watched the recordings that I have done on the compound interest problems. So please go back. There's several recordings that are out there where I've discussed solving interest-related problems where the interest is being compounded continuously and also where the interest is compounded periodically. Please watch those recordings before you watch this one, because this one we're going to be using the methods that were taught in those videos. And so hopefully we can move just a little bit faster in this video going through those methods. The purpose of this particular video is to help you understand how to approach problems involving functions in general. In the previous recordings, we looked at problems that were specific about interest. Okay, so we're going to step away from those very specific problem types, and we're going to examine how you might approach just any general problem that involves a function. So let's take a look. Here's our sample problem. A theme park determines that it can project its profit, P of X, in thousands of dollars based on the number X in thousands of park passes it sells with the following function. P of X equals negative 2x squared plus 260x minus 7,500. So the question is, how many park passes must the theme park sell in order to have a positive profit of $800,000? So we're going to move through a couple of different strategies, approaches on how to solve this problem. The first thing I would recommend when dealing with a problem involving a function, before you dive into trying to solve the problem, make sure you take a moment to understand the context of the problem. That will really help you. For example, I want to figure out first what the two variables represent in this function. So there, when you have a function like this, there's always going to be two variables. You have your dependent variable. In this case, that's P of X. That's the dependent variable. And the independent variable, which is going to be the variable that's in your function, in this case, X. So I just want to take a moment just to, read the problem carefully and just think about what the two different variables represent. All right, so like, for example, P of X, what does P of X represent? What does that notation represent? Well, just go back to the wording of the problem. So the problem is going to explain to you what the variables represent. You just have to make sure that you find it. Okay, so up here it says, it explains what P of X is. It says it's profit in thousands of dollars. So that's the theme park's profit in thousands of dollars. That's what P of X represents. So that's profit. The X variable is explained in the second row here, the second line. So the X is the number in thousands of park passes the theme park sells. Okay, so X is the number of park passes the theme park sells in thousands. So it's helpful to just kind of get your mind wrapped around like what's going on in the context of the problem. So the profit, being the dependent variable, depends on the number of park passes that are sold. And this function is going to describe the profit when you sell a certain number of tickets. All right, so let's take a look at how this works. we're going to take a look at how to solve this algebraically first. Okay, so let me switch over to my other screen. This always takes just a moment here. Okay, so here is the function from the problem. All right, and the question is how many park passes must be sold, the profit to be $800,000. So what we'll do is, we're always going to fill in anything that we know into our function. Okay, so, essentially a function is an equation. All right, so this is just an equation. And, if we know the profit, then we need to plug that in. All right, so the profit is 800,000. So just go ahead and plug that right in there and just bring everything else down. Okay. Now, what type of function is this? We know that this is a quadratic function. It's a quadratic function. We know you guys have studied this in your class. And we know that it's quadratic because of the power of 2 there, and that's the highest power in the function. So it's quadratic. And we know that with a quadratic equation that, typically what we want to do is we want to get a 0 on that one side. So in this case, and by the way, let me actually do something here now. I wrote in 800,000, but be careful with that. The profit is expressed in thousands. All right, so to express $800,000, I actually don't want to write 800,000. All right, so I actually just want to write 800 because the profit is already expressed in thousands. So by saying 800, that's understood to represent $800,000. Okay, so actually don't do that. So be careful with the wording of the problem. All right, so now let me go in here and write the rest of this. And as I was saying, the typical standard approach to solving a quadratic equation is you want to get a 0 on the one side. So we want to subtract 800 on both sides, and that will give us the 0 that we want. And negative 7,500 minus 800 is going to be negative, 8,300. All right, just verifying that on my calculator. All right, so it's a quadratic equation, so I'm going to go ahead and just make use of the quadratic formula. And the formula is x equals negative b plus or minus the square root of b squared minus 4ac, and that's all divided by 2 times a. All right, and you guys know how this formula works. The coefficient in front of x squared, that's your a. The coefficient in front of your x term is your b, and your number here, your constant, is your c. So that's how you know what to plug in where. All right, so we're going to put in the opposite of b, negative b. B is 260, and that's plus or minus the square root of b squared, 260 squared, minus 4 times, now a is negative 2, all right, and then times c, that's negative 8,300. Squeeze that in there. And that's all divided by 2 times a, 2 times negative 2. So that will become negative 4 down there. All right, so let me just try to simplify some stuff here. So negative 260 plus or minus the square root All right, so let me type in my calculator, 260 squared. That's 67,600 minus. Notice I've got the 4AC part inside parentheses. I recommend that you always do that. Always put in 4AC inside the parentheses there. That will make sure that you keep your signs correct. All right, so what's inside parentheses is 66,400, and it's positive because I have two negatives being multiplied together, so that's going to become a positive, and then a positive times a positive is a positive. So, all right. Let's go ahead and simplify what's inside the radical, inside the square root there. So looks like that difference is going to be 1,200. So we have plus or minus the square root of 1,200 over -4. All right, so we're close to getting our answers. So we have a plus or minus. So we want to write out two different solutions here. So we have -260 plus, I'll write plus this first time to write out this first solution, plus the square root of 1,200, and that's divided by -4. All right, so there's one solution. I just need to work it out in my calculator to see what that equals. And then the other solution is going to be -260 minus radical 1,200. And that is over -4. Okay. All right, so let me go back to this first solution here. Let me work through that with my calculator. -260, I'm just typing this right in, plus the square root of 1,200 equals, and then divide by -4. All right, so that first solution looks like it's 56.34, rounded off to 2 decimal places. All right, and let me go back to this solution. And I'm just going to type all this in my calculator, -260 minus the square root of 1,200 equals, and then divide by -4. And that looks like that equals 73.66 rounded. Okay, so I've got my two solutions to my quadratic equation. All right, and so let me think about what this is telling me. So remember now the X is in thousands. Okay, so what this represents then is that approximately, if the theme park sells approximately 56,340, and we have rounded this off a bit. So somewhere around 56,340 tickets, then they will have a profit, a positive profit of $800,000. And then also, if they sell approximately, now again, these numbers represent thousands, okay? So this is equivalent to 73,660. So if they sell approximately 73,660 tickets, then they also have a profit of about $800,000. Okay. So that's interesting. All right. Now, let me go ahead and talk to you about a graphical approach. Okay, so this is the algebraic approach. We have our two solutions to the problem. If you want to do this graphically, then let's use our two methods that we have learned. Okay, so let's talk about the zero method. Now remember, with the zero method, once you write your equation, okay, so here was the original equation that we want to use up here. Once you write that equation, you also want to get a zero on the one side, just like we did with the algebraic approach. So you want to go ahead and subtract 800 on both sides to get that zero. All right. And let me just go ahead and write the equation that we would have. So we have 0 equals it would be negative 2x squared plus 260x. Is it plus 260x? Yes. Minus 8,300. Okay. And then remember what you do. So once you have that 0 on the one side, then you actually want to just graph this function right here. And the goal is to figure out, what values of x would make that function value be equal to 0. All right, so let's just do it in the calculator. And let's see if we get the same solutions that we got from the algebraic approach. Okay, so let me change my screen. All right, so here's my calculator. Let me get situated here. All right, so I'm wanting to graph that function. So I'm using the 0 method. All right, so just hit y equals. I'm going to clear the functions that I have in there from my previous examples. All right, and so in y1, I'm just going to type in my function. So I've got negative 2x, and I'm going to hit this to raise that to a power of 2. And then I hit my right arrow key to bring myself back down from the exponent, plus 260x minus 8,300. Now I want to graph this function, and then I need to find the 0. Okay, so that's how this method works. Now, before, just like I talked about before, guys, so important to understand the window. So before we just jump in and try to graph this, we want to go to the table of values. Okay, so hit second table. And remember now, the goal is to find the 0 of the function. So you want to look at the y column, and you want to try to find about where it becomes 0. Notice these negative values, they're getting smaller and smaller. So we're heading towards 0. Okay. And so it looks like there's a 0 occurring right in here. All right, and we know that there's 2 solutions to this quadratic equation because we just did it algebraically. And so I'm going to look for the other 0. Aha, here it is. So there's another value of 0 right in here somewhere. Okay. So to graph the function to where I can see both zeros, I want to think about the x values that I want to make sure that I can see. Okay. So, this 0 here is happening between 73 and 74. And the other 0 is occurring right here at about 56 or 57. So I want to make sure that I can definitely see those couple of values. But, I want to expand the range around those values, just kind of spread it out a little bit, just to make sure I can, easily see those 2 values. All right, so I think I will start my window at a value of x equals 50. That's quite a bit less than where this first 0 is. So I'll go from 50 to, and then, the other 0 is right in here at 73 or 74. So I think I'll just go ahead and go out to 80. Okay. So my range for my x's is going to be from 50 to 80. All right. So let me go to my window. Let me click on window. And so my x minimum is going to be, let me clear this, is going to be 50. And the largest x value that I want to be able to see is 80. That range of x values will ensure that I can definitely see both zeros. Okay. All right. Let me do the same thing for the y's. Okay. So do second table. Just kind of get a feel for, how large or how small the y values get. Okay. So, looks like the Y values in between the two zeros go as high as about 150. Okay. And then of course they go to a value of 0. All right, so I want to go as high as 150. All right, so here's what I'll do. Let me go to my window. So the smallest Y value that I want to see. Now, of course, we're finding zeros. So, when we find the 0, we know that the Y value is going to be 0. But I want to have the window dip down a little below that value of 0, just so I can see things really well. Okay. So I'm just going to go ahead and say, let's make the Y minimum be negative. I'll say negative 100. Oops, and let me go back. I've made a mistake there, which is good because it's probably a common mistake. When I was going to type in that Y minimum, I actually hit minus for the negative. Make sure you hit this negative button to get a negative on the screen. So let's do negative 100. I'll do negative 150. For the Y max, I want to go on up. So, it looked like the values got as high as like 150. So I want to go ahead and move on up. Let's put in 250 just to make sure I've got plenty of space in my window. All right. When I feel good that I've got my ranges correct for my X's and my Y's, I just hit graph and see what a great graph we have. We can see the important parts of the graph, okay? All right. And then for this method, what I want to do is I want to find these two zeros right here. This right here is the x-axis. Here's my function. And where the function goes through the x-axis, those are my zeros. All right, and to find the zeros, we want to do second trace, select 0. And I'm going to work on this one first, this left one. Now, to get that one figured out, it says left bound. So I want to move my cursor left by hitting the left arrow button. And I'm going to have to move it on down here, for that cursor to be a little to the left of where this, it's on the graph, but it's to the left of where this 0 is. Okay, so that's going to be a good left bound. So I hit enter. And then it wants a right bound. All right, so I want to hit the right arrow key to move right. And put some distance between the cursor and the 0 that you're trying to find. All right, so it's on the graph, but it's to the right of where the 0 is. So just hit enter. Notice it puts flags above where you set those bounds. You just want to make sure that the 0 that you're trying to find is actually in this interval that is marked by the flags, and it is sort of right in the middle there. Once you have that set, just press enter. All right, and check it out, guys. Here is one of the solutions that we found algebraically. So 56.34 rounded is one solution. All right, so to get the other solution over here, this other 0, let's do second trace. We want to select 0 again, enter. Now it's asking for a left bound, but now I'm going to work on this 0 way over here. Okay, so I got to move my cursor over, so I'm going to hit the right arrow key to move it over a little bit. Now I'm going to stop right there because that's a good point. That's to the left of this 0 that I'm trying to find. Okay, so hit enter there. It puts a flag above where we set that. Now it's asking for a right bound. So I hit the right arrow key and move it along the function to a point that's to the right of the 0 that I'm trying to find. This is to the right of that point. So I hit enter. And it puts a flag right over that. Just make sure the 0 that you're trying to find is inside this interval that's flagged. All right. And as long as it is, you're ready to guess. So hit enter for the calculator to find that. And there it is, guys, 73.66. That's the other solution. Nice. Okay. So again, so what that's showing is for the park to have a profit of $800,000, they have to sell those numbers of tickets. So this indicates that they have to sell 73,660 approximately And then we have the other solution as well. Okay. Now let me go back to my presentation. Let's answer a couple of additional questions. So, we want you guys in Math 1710, we want you to be able to analyze graphs to answer some questions. We want to make sure you fully understand how the graphs work and the functions. So let's practice answering a couple of additional questions before we close this video out. Here's a question. So how many tickets must be sold for the park to make any positive profit? How many tickets must be sold for the park to make any positive profit? Well, let's examine this graphically. All right, so let me go back to my calculator. Now, to answer that question, what I want to do now, we're not talking about what makes the profit be $800,000 anymore. Okay, so my function is going to be, I just want to type in the original function that the problem gave me, the sample problem. So let me just clear this one out and let me retype this in. Now I'm going back to just the original function. So I don't want to, I want to hit this negative button. So negative 2x squared plus 260x. Now I'm doing minus 7,500 because that was the original function, okay? This function just represents the profit. This is the original profit function. I want to graph this to see what it looks like. Now, I'm going to have to think about my window again to make sure I get a good graph. Okay, so I want to hit graph. Oh, well, I didn't really want to hit graph. I want to hit second table to take a look at my table of values. Okay, I'm just getting a feel. So what I'm looking at is I'm just kind of getting a feel for how large the Y values might get and how small they might get. Okay, so see how it kind of peaked. So the values kind of peaked right there at 950. Okay, so I want to make sure that I can see at least that value for Y. Okay, and all right, and the values also go negative. Okay, all right. So let me go to my window. So for my Y's, I want to see at least 950. So let me just put, I'll put 1200 just to make sure I, have a good range of Y values in there, just to make sure I can see at least 950. And then I'll let the Y minimum, I'll just go ahead and say negative 1200 on that one, just to make sure I can see down below the X-axis quite a bit as well. So now I want to think about my X values. Now the X's, let me go back to my table of values. The X's, just to make sure I can see everything well. Let's see, it looks like the peak happens right here at X equals 65 or so. Okay. Okay, then it goes negative. All right, so to make sure I can see the peak and enough of the rest of the graph, I think I will start my X values at 30. And I will extend those, so there's the peak going by there, okay, and then the Y values then are going negative. So let's say from 30 to out to 100. It seems like that will likely get most of the important parts of the graph in, okay? So we're going to go from 30 out to 100. Let's see what the graph looks like. And we have a nice looking graph. We can see the entire thing. So we did a nice job of picking out a correct window. All right. So now think about what this represents, guys. The graph represents the profit for the theme park. Now you've got to think about the y values. Think about the value of this function. Think about the value. All right, so right here, because the graph is right there at the x-axis, think about what is the value of the function right there. The value is 0, right? So they would have 0 profit right here. And they also have 0 profit right here, all right? Because the value of the function at those 2 points is 0. But as they sell more tickets, all right, so, we can find out what this X value is here, but as they sell more tickets, at some point, they actually max out their profit, okay? And you're going to see how to find that maximum profit in another video. But there's gonna reach a point here where there's a maximum profit, and then, but as they sell more tickets, the profit actually begins to drop off, okay? And then they're heading towards making 0 profit again. And after this point here, if they continue selling tickets, if they sell more tickets than whatever this is, then they actually slip into a negative profit. And so they're definitely losing money at that point. Okay, so going back to the question, how many tickets must be sold for the park to make any positive profit? So they're making a positive profit as long as the graph is above the x-axis. Okay, so what we'll have to do is we'll have to find these 2 zeros, and then we can figure out what these values are. So let's do second trace 0. And I want to find this 0, okay? So I'm going to move left. I need to get my left bound. I'm going to do this kind of quickly because you guys know how to do this now. So there's my right bound. Oh, I'm sorry, there's my left bound. There's my right bound. And enter. All right, so we're seeing that if they sell at least 43,000, approximately 200 tickets, 43,200 tickets, then they begin to make a profit as they sell more tickets than that. All right, so basically they have to sell at least 43,200 and a little bit more here tickets to actually break even. And then as they sell more than that, they reach a maximum profit at some point. All right, and then at some point over here, they're going to zero out again on their profit. So let's find this other point. So to find that, I'm going to find the 0. So second trace 0. I'm going to get my left bound. That's a good one. And then get a right bound. So move to the right of where that 0 is. All right. And the calculator has found that they reach 0 profit again if they sell about 86,794 or so tickets. All right. So this is saying that as long as the theme park sells, somewhere between, and I'm rounding these numbers off a little bit, but somewhere between 43,200 tickets and 86,794 tickets, then they make a positive profit. They would be along this part of the graph here. Okay. Here's one more question for you to think about. Does the park make more profit by trying to sell as many tickets as possible? Does the park make more profit by selling as many tickets as possible? The x-axis here represents the number of tickets sold, okay? So if the theme park sold more than this number of tickets, then they begin to drop down into the negative profit, right? So, as you go along the graph here, your profit drops into the negative category, all right? So it turns out that, no, that's not exactly how it works. It turns out that, once they reach this maximum value of profit, after that, if they sell more tickets than whatever this amount is, their profit actually is shrinking And then eventually, if you go past this point, if you go past this number of tickets, then the profit becomes negative and they're actually losing money at that point. All right, so that's kind of interesting. So make sure this makes sense to you guys. So, this represents the profit value, this graph. This is the dependent variable, all right? And the independent variable is represented along the x-axis. So if the theme park sells less than 43,200 tickets, they're not making a positive profit. They're over here down below the x-axis. So these y values are negative, so the profit is negative. The profit is positive anywhere from this number of tickets to this number of tickets. Because you have a positive value, you're above the x-axis here. Okay. Okay, everyone. This was a longer video than what I intended, but it's a lot of good things to think about. Kind of quiz yourself. Make sure that you understand everything that's being said here. Make sure that you can find windows properly for your graphs, and make sure that you understand how to solve these types of problems. All right. And we will see you in the next video. Thanks.